In this video, I'm going to go over a basic example of one-dimensional interpolation. The basic idea behind interpolation is that we can find the value between two known points on a line or curve. And this is useful to find missing data points, for example, if we're working with real data. Here we have a sine function, and this top curve has pretty sparse data points, and we want it to look a lot more like this curve below, which looks like a sine function that we normally think of. Let's start with the original curve. We're going to make the d theta equal to pi over 2, and theta is going to be equal to 0 d theta to 2 pi, so 2 pi, and then y sine theta. So those are going to give us those sparse data points that we saw, but let's go ahead and take a look. Figure 1, plot theta, y, okay, and let's also look at the data points. So theta, y, we'll make them magenta triangles, and let's also specify the axis. So axis minus 0.5, 7, minus 1.5, and 1.5. So that's what we get. This is the same as we had before. As you can see, the data points are pretty sparse, and it doesn't look a whole lot like a sine function. So we're going to use interpolation to make it look a lot more like a sine function. In interpolation, I said we use the existing data points to find new ones. And the way we do this in Matlab is we do this by specifying the frequency with which we look at the current values in two vectors containing the known data points in order to find the new ones. And those two known vectors I'm referring to are these two, theta and y. And so we're just going to make our new frequency first. So d theta is pi over 20, and new frequency 0 d theta 2 times pi. So we still have the same bounds here, but now we are sampling much more often. So the way that we use the interp function is new y, which are going to be our new y values, and that's going to be, we're going to use interp 1, and our old sampling frequency, theta, our old y values, y, and our new sampling frequency, so new freq. And so let's, we can run that, so I just ran that, and let's use a subplot to see what they look like side by side. So figure 2, subplot 2, 1, 1, and this is going to be the same thing as above, so I'm just going to copy and paste that, and then we're going to have subplot 2, 1, 2, plot new freq, new y, and let's make it a red line, and let's look at those points as well. So we'll have new freq, new y, and then BO, round circles, or blue circles, sorry. Just want that. And let's make the same axis. So make that. And here's what we get. And so the default method of interp 1 is to do linear interpolation. So that means we're just going to pretend that this function is linear rather than a sine function, for example, which is not linear. The way we make it not linear is by changing the method. So we're going to make it spline. And so I'm going to run that and run this again. And so as you can see, now we get something that looks a lot more like a sine function. So one other interesting thing you can do is extend the bounds of your new frequency to extrapolate this function. So for example, we don't want to just end here, we want to end maybe out here. So let's make that 2 pi, 2.5 pi, run that, and I'm just going to comment this out. And so here, I mean, this isn't the best, this probably isn't the best extrapolation, but I mean, you can use that on a lot of different things. So it's a good thing to keep in the back of your head.